morning, students. This is the electronic measurement and instrumentation subject, that is EC304, and our topic is measurement parameter and bridges. Now we start with our first topic, that is introduction to the measuring instruments. Measuring system exists to provide information about the physical value for some variable being measured. In simple cases, the system can consist of only a single unit that gives an output reading or signal according to the magnitude of unknown variable applied to it. We can understand with the help of diagram input variables when applied to the sensor, next to the variable conversion element, next to the variable manipulation element with the signal transmission, to the data processing element, next to the presentation element. So the output uh, take at the observer side. Next, the instrument can be defined as used to determine the present value of the quantity under the measurement. And measurement, it is the process of determining the amount, degree or capacity by comparison with the accepted standard of the system unit being used. Now the accuracy, the degree of exactness of a measurement compared to the expected value. Resolution can be defined as the smallest change in a measured variable to which an instrument will respond is called resolution, and the precision is the measure of the consistency of measurement, that is successive reading does not differ, and expected value, the design value, the most preferable probable value that calculation indicate one should expect to measure, and the error, the deviation of true value from the desired value, and the sensitivity, the ratio of the change in output of the instrument to a change of input or measured variable. This can be understood with the help of diagram. Accurate and precise. What is the difference between the accurate and precise? The first one shows the accurate and precise one. The second image shows the not accurate but not precise but precise. And the third one shows the accurate but not precise. And fourth one, that is both not accurate and not precise. Now the tolerance is the term that is closely related to the accuracy and defines the maximum error that is to be expected in some value. The range is of an instrument defines the minimum and maximum value of a quantity that instrument is designed to measure, and dead space is defined as the range of different input values over which there is no change in output value. The static error are the two are of following types of error. The first one is cross error. This error is mainly due to the human mistake in reading and or in using instrument, or in error in recording observation, but it can be minimized with the error cannot be treated mathematically. The complete elimination of gross error is not possible, but one can minimize them. Systematic error is the error occurred due to shortcoming of instruments such as defective or worn parts, aging effect of the environment on the instrument. And these there are basically three types of systematic error. First one is instrumental, second one is environmental, and the third one is observational. The first one, instrumental, can be defined are the inherent in measuring instrument because of their mechanical structure. Second one is environmental error. It is due to the condition external or to the measuring device, including condition in the area surrounding the instrument, such as effect of the change in temperature and humidity, or any kind of pressure of magnetic or electrostatic fields. These are the error can be also avoided by air conditioning, hermetically sealing certain components in the instrument, or using magnetic shield. The third one is observational error. These are introduced by observer. The most common error in the parallax error introduced in reading in meter scale, the error of estimation when obtaining a reading from a meter scale. These errors are caused by the habit of individual observer, and we can understand with the help of this example. Now the method of measurement. These are the 6 methods through which we can measure our instrument. The first one is direct, next is indirect, comparative, substitution, null, and fundamental method. We can start with our first direct method, that is direct method. Direct method measurement is the value of a quantity is obtained directly by comparing the unknown with the standards. It involves no mathematical calculation to arrive at the result. Measurement of resistance by ohm meter, measurement of length of cloth with scale, with the help of scale. Indirect method, it is when direct measurement is not possible, so we can use the indirect method. Direct method is measuring exactly the same quantity you want to measure, while indirect measurement is measuring other quantity and required values is determined by mathematical relationship. With the help of example, we can understand volume is equals to mass upon density. Measurement of volume by measuring the mass and density. Speed is equals to distance upon time, that is measurement of speed by measuring distance at time. The third one is the comparative method. It is the quantity to be measured is compared with the known value of the same quantity. Examples: comparing a sound level meter with the reference sound level meter, and etc. Now the substitution method involves the replacement of the value of quantity to be measured with the known value of the same quantity. And the example are calibration by weight by substitution method. The null measurement method, the quantity to be measured is compared with known quantity and the difference between these two is made zero. Example: measuring unknown resistance using Wheatstone bridge. The fundamental measurement is based on the measurement of the base quantity used to define the quantity. Example: measurement of temperature by fixed point apparatus. DC meter, M meter construction is typically used a permanent magnet moving coil, that is PMMC, where the coil is placed in the field of permanent magnet. The deflection is proportional to the current, and since DC is unidirectional, deflection we have getting is steady. The mechanism measures current based on magnetic force that attracts the coil and rotate it against the spring. The scale is we are getting linear. And measurement suitable only for DC current, because reversing the direction of current would reverse the pointer's deflection, and we get error reduction by swamping resistance is added in series to reduce the effect of temperature changes in the reading. Now the next is chopper type DC voltmeter. Its working principle is the DC input voltage is periodically interrupted by modulator to create AC signal. This AC signal is amplified by AC amplifier and later demodulated back into the DC signal that is proportional to the original input. We can understand with the help of example having chopper modulator, AC amplifier, chopper demodulator, and LPS, that is low pass filter. With the help of oscillator we getting our amplified output, that is DC. And here are the advantages and disadvantages of chopper type DC. Solid state DC voltmeter. Its principle is to utilize solid state electronic components such as operational amplifier to perform the voltage measurement and amplification. Benefits are offer very high input impedance, which means it draws minimal current from the circuit being measured, and often includes features like over voltage protection using diodes. Mechanism involved is uses ICs, that is integrated circuit and feedback loop, to provide stable and accurate measurement. The term can also refer to other technologies like solid state batteries, but in the context of voltmeter it refers to the use of modern semiconductor components. The AC voltmeter using rectifiers. Here is the average and RMS value of current. Rectifier type instrument generally use a PMMC movement along with a rectifier arrangement. Silicon diode are preferred because of their low voltage current and high forward current rating. Gives an AC voltmeter circuit consisting of multiplier, bridge rectifier, and PMMC. Average responding voltmeter, how it works? It takes the average of the waveform, full wave rectified output, then uses a conversion factor to display RMS value assuming a pure sine wave. Calibration scale is typically calibrated in RMS volt, but it uses the average value to make its reading. Accuracy, it is only accurate for pure sine wave. For any other sine wave, the reading will be inaccurate because the average value is not directly proportional to the RMS value. Now the next one is peak responding voltmeter. How it works? A storage capacitor charged to the peak value of the applied AC voltage. This peak voltage is then amplified and displayed by the meter. Its type is DC coupled and AC coupled. DC coupled is the meter reading is affected by both AC and DC components, and AC coupled is defined as it only responds to the AC component, making it more useful for AC measurement. The accuracy is it provides an accurate reading of the waveform peak value, but this is not always the most useful measurement for determining power or effective voltage. RMS responding voltmeter, that is root mean square. How it works? True RMS voltmeter and can accurately measure the RMS value of any other AC waveform, including those with the complex shapes and harmonics. Its purpose is to represent equivalent DC voltage that would produce same amount of power in the load. And its accuracy is most accurate type of AC voltmeter for general purpose measurement, and it provides two true measure of waveform effective power. Now the multimeter, it is used to measure electrical values. It is made up of two words, that is which means two or more meter, and most commonly voltmeter, ammeter or ohm meter. Each of these instrument tools can be used individually within the multimeter. Bolometer, its principle measures by using a temperature sensitive resistor, and it works as the resistor is heated by incident power causing its resistance to change. This change in resistance is measured often using a Wheatstone bridge circuit and is proportional to the absorbed power. The application used for measuring low to medium microwave RF power in a range from 0.5 megawatt to 1 watt. And the calorimeter principle measure energy power by observing the temperature change of a substance. The term calorimeter refers to the science of measuring heat and how it works, measuring the heat absorbed or released by substance. For power measurement, this often require a well-defined heat capacity and way to measure temperature change over time. The application used in many scientific fields for a wide range of energy and measurement, and its principle is fundamental to both. How a bolometer operates through a bolometer is a specific type of device built to measure power at high frequency. What is power meter? The power meter is most useful and simple instrument to measure electrical power, where no deeper analysis of the measured data is required. It measures the voltage and current and derives from these the most important power result. Power meter are perfect for technician and engineer performing simple tasks like standby power measurement. And the typical application for a power meter is to use accurate and preferred instrument for cost effective power measurement solution for a wide range of applications such as production line testing of electric device, efficiency measurement for industrial motor, etc. Thank you.